Hey everyone, welcome back. Today's day 4 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, explaining them and publishing the videos on YouTube for all of you. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. And right now, I'm in top 0.3% on LeetCode at a global level. And like most of you, I'm also preparing for FAANG interviews. So far, we have covered sliding window, two-pointer, partitions, and prefix and suffix patterns. Today, we are diving deep into string problems, such as substrings, character counts, anagrams, and all the classic tricks interviewers love to test. Before I begin, if you love this video, please drop a like, share it with your friend, and please hit that subscribe button so we can crack interview side by side. Let us go. So the problem number 2 for today is lead code 49 group anagrams. I have already done lead code 242, which was a problem based on just identifying anagrams, where I have explained in great detail about various things about what anagrams are, how to come up with a structure for the anagram using array and dictionary and stuffs like that. So please buckle up your belt because in this video we are going to move pretty fast. Okay, so what do we have here? We have to group anagrams, and we have been given a string as a list that contains several words, and we have to group anagrams, common anagrams, into a list and return that. Let us go to the dashboard and we will try to find an optimal solution for this problem. But before we go there, let us just look at a constraints. Okay, so the constraint is reasonable. Now to the dashboard. We have been given strings which contains several strings as a list, and these are the words, and we have to group anagrams. For an example, nat and tan are anagram because the frequency count is same, correct? How do we approach this problem using brute force? The brute force method to approach this problem would be, hey, we start from the first character and we scan towards the right, finding each and every anagram for this character. Similarly, we repeat the same thing for this character, for this character, for this character until the end, okay? So that path will be of order of quadratic because we will be looping twice in a list in a nested manner, and it is something that we cannot afford, okay? So we will not take the quadratic path. So if not quadratic path, then how will be the optimal path? But before I go to the optimal path, let me give you a very basic example. Suppose I have two strings, ABC and CAB. It should be pretty evident that these two are anagrams. How do I determine that? One of the method is using the dictionary, but I'll be sticking with arrays, okay, because it is much more intuitive to me. So we see that frequency count of ABC is 111, frequency count of CAB is 111, okay. I will not call this array as an array for now. I will simply call it as a frequency structure for ABC and frequency structure for CAB. What do we notice? We notice that these two frequency structure for ABC and CAB are identical. And since they are identical, so we return true, or we can say that ABC and CAB are anagram. Cool. All right. Since I've explained the frequency structure, let us come to the next part, which is very critical for our solution, and it is the data structure that we will be using, and it is dictionary. Okay, we know that dictionary has this structure, key value pair, right? For our dictionary, our key will be the frequency structure. What is the frequency structure? These things, right? These arrays that we've assembled, I'm calling that as the frequency structure. So the key of the dictionary will be frequency structure, and the values of that frequency structure will be a list of all those words whose frequency structure matches this frequency structure. For example, look at this part. Frequency structure for ABC and CAB are 111. So I place the frequency structure as the key, and the values will be all those words or strings whose frequency structure matches this one. Let us ask, hey, what is the frequency structure for ABC? It is 111. Does it match this key? Yes, it does. So let us append ABC in the list over here. We come to CAB. Hey, what is the frequency structure for CAB? It is 111. Does it matches the key? Yes, it does. So please append CAB in the same list of these values, right? In the bottom, Like in the crux, what I'm trying to tell you is that the structure of our dictionary has two main components, key and values. Key is the frequency structure, and the values are the list of all those words with a similar structure. Remember this thing. If I have come up with some structure or frequency structure for a word, and when I make a double scan afterwards, and if I encounter some different words which has the same structure as the first one, then I will place all those words as the values in the list of the frequency structure value, okay, as it is done over here. So this is the objective what we are trying to accomplish here. We will scan from the strings from left to right, and at every state of the index, we will create the or we will build the frequency structure for every word. And once we do that, we will ask, hey, the frequency structure of the word that I have built, for example, the frequency structure for 8 that I have built, is it present in the dictionary that we have already built? And if it's present, the frequency structure for 8, then please append 8 in the list of its values, okay? Because it is already present. For example, if we are looking at T, assuming that we have already added a frequency structure for 8, we'll see that the frequency structure of T, it matches with 8. How do we check that? We check in constant time in the dictionary using the frequency structure. And once that is done, we'll append the value of T in the list of those values. As you can see over here, 8, T, and 8. All of those are present in a similar list, in a single list. Why is that the case? Because these three have the same structure of frequency. Similarly, NT and TN and BAT is alone because there is no single words in this list, entire list, that matches the frequency structure for BAT. Cool. Now let us come to the code, which is the easy part. Initially, I have defined a dictionary, an empty dictionary, and then I will iterate through the every word in the strings, okay? And as I go there, I will do what I will do is I will create a empty frequency structure. Remember, frequency structure is this thing, an array, right, of length 26, and I will assign every value to 0, and I will create a length 26 frequency structure. And then what I will do, the word, this is the iterator, right? I will scan through this word, which I'm doing over here, and for every single character that I'm finding, I will find a mapping for that character in the array, and then I increase its value by +1. Cool. Once that is done, I will ask, hey, the frequency structure, this frequency structure, hey, does this frequency structure exist in dictionary? And if that frequency structure exists in dictionary, what does it mean? It means we have already found in the past a similar frequency structure for a different word, and that was already existing in dictionary. And since for the current word also, this structure is for the current word, right? This word, right? And for this current word, the structure is already pre-existing in the dictionary. In that case, what I will do, I will simply append word to the values of that key, which is the frequency structure. But let us suppose if that frequency structure that we're encountering is for the first time ever, right? So in that case, we will simply add it as a key, and the value will be the list of the word, the frequency structure we have built for, okay? And later on, let us suppose far ahead, we encountered something similar as this one, we'll append that word over here, right? So that was all there was to this problem. Once we exhaust this loop, we'll come out of it and and we'll scan the entire dictionary, and we'll return the list of lists as the values for the answer, right? I mean, the values for the dictionary will be all those words that we have assembled, and we will be iterating over the keys, and we will be collecting all of those in the list of lists, right? Something like this, and it is something that will return at the end, okay? The time complexity is order of n, bounded within linear because of this thing, and because of this thing as well, you can tell. And what is the space complexity? Since our characters or strings is limited just to the English alphabetical letters. So I'm assuming it is of order of 26, which is more or less constant. Cool. Let us go to the dashboard of LeetCode and we'll try to submit a solution and see how it goes. I've already submitted a solution. So let me just copy and paste my code and let us see how it goes. Oh, by the way, before I submit the solution, let me tell you something. Let us look at line number 8 over here, okay? What was the need of that thing? Why did I converted my array into tuple type? I did so because if you come over here, key of the dictionary must be of immutable type, okay? The dictionary key, which is a frequency structure, initially it is an array, Array is not of immutable type, right? Array is something that can mutate. We can append, add, decrease, increase size, whatever we want, right? But the key must be of immutable type in the dictionary. So in Python, what we do, we translate this array into tuple. Why tuple? Because tuple is immutable. And if we are to store the frequency structure, we must store it as an immutable type, not as a mutable type, okay? That is why we converted this array into tuple in the code section, as you can see over here on line number 8, okay? So once that is done, let me just run this code and you will see the solution has been accepted and all the test cases has been passed, okay, as it is shown over here, right? So yeah, that was all there was to this problem. I hope you enjoyed it. I hope you understood everything that I was trying to explain. If you have any doubt, please watch my previous video for day 4, LeetCode 242, where I've explained in great detail the structure of the anagram and how to come up with that and stuff like that, okay? See you in the next video. Till then, take care.